Welcome to Mr. V Teaching Math. In this session, we're going to be looking at equations in algebra that have two unknown variables. And how in the world do we find the answer to this kind of equation? However, before we continue, please make sure that you have gone and learned about the coordinate plane. The video in which I teach this topic is Mr. V Teaching Math Coordinate Plane. It would be a really good idea to go and review this topic before we go any further. So for those of you in my classroom, stop this video, go search for this on YouTube, and watch this video. Now, how in the world do we find the answer to this question? Well, none of the tricks that I've learned so far in algebra are going to work because there are two unknown numbers. But there is another way of doing it. And here is how it's going to work. What I'm going to do is I'm actually going to do is I'm going to demonstrate all of the possible answers to this question. There's an infinite number actually, but I'm going to show you how to demonstrate every single possible answer to this equation. But to get there, there's some work I have to do first. I'm going to create a little chart like this. And I'm going to pick some numbers for x, anything at all. If I felt like putting 2,678,000 in here, I could. I am going to pick numbers that are easy to use, though. For many students, these three are the easiest. And I'm just picking them almost at random. I happen to be picking 0, 1, and 2 because they're easy to work with. Some people like to do -1, 0, and 1. Some people like to do 1, 2, and 3. It doesn't really matter what you pick. I am picking low numbers because otherwise it won't fit on my chart later. If I were to put 1 million or 7,000 or whatever number I put in here, I'd have to make a really big chart later on. So I'd rather use small numbers. Now, what is y when x is 0? Well, how about I go find out? I'll take the 0, and I'm going to go put it over here, and we're going to find out what y will be if x is 0. I'm going to learn to use some of the skills I've done before. I'm going to substitute the variable. I'm going to replace x with 0. And this question is quite easy as questions go. When x is 0, y will be 1. So, in this case, x is 0, y is 1. Now, what if... I have to do two more. When x is 1, as many of you can already see, you know that it's 2. And yes, even though it's obvious to many of you, I'm going to require in my classroom at least that you show all of this work when doing this kind of equation. Take the 2, substitute it in for the x. Of course, the reason I'm requiring all that work is because some of the equations we're going to do are much more complicated. So when x is 2, y is 3. Now what does this give me? Well, I can then do this. I have xy coordinates. X is 0, y is 1. X is 1, y is 2. And these coordinates can be graphed. So, let me graph these coordinates. The first coordinate, x 0, y of 1, that'll be right here. Second coordinate, 1, 2, x1, y2. Third coordinate, 2, 3, x of 2, y of 3. And then I'm going to line up the dots. I'm going to draw a line, putting an arrow on each end to show that that line goes into infinity. Oh, I drew my line a little bit crooked, but it'll still get the idea. This line represents all of the possible answers that exist in the universe for this equation. This line is the answer to this equation. Let me demonstrate. What if x were 4? Well, if x were 4, y is 5. Here's the x of 4, y is 5. What if x were negative 1? X of negative 1, y is 0. What if x were negative 6? Here we go. Negative 6, the y will be negative 5, right over here. This line shows all of the possible answers. I chose to do 3 coordinates because with 3 coordinates, they have to line up to form a straight line in this type of equation. Later on in math, you will find lines that curve and so on, but at this stage, they will all form a straight line. By choosing 3 points, if they line up in a straight line, I probably did it right. If for some reason one of my dots ended up over here and it didn't form a straight line, I would know that that must probably I've made a mistake somewhere. But there is an example of how to put all of the answers for this equation and show them.